Good morning and welcome to today's Fusion Friday, our monthly Fusion Friday, that is. Fusion Fridays are here to provide you guys good morning and welcome to today's Fusion Friday. You guys, might need to know. Also, any latest Fusion 360 updates, and also to go over some of the workspaces that Fusion 360 has to offer. My name is Alex Alvarez, and I'm joined here along by
Brian
Mangapacific, right? That is, and we're both application engineers here at Conceive. So our main role is to provide support for any questions that you might have regarding Fusion 360, and just answer any questions that you guys have on the software. Today's topic is static stress simulation. So why is that important, right? So once you design your part, before actually manufacturing it or creating a prototype for it, you want to make sure that it's going to withstand the test of time. You want to make sure that it works before you actually send it out to production. So that's why we're going over static stress simulation. In case you did miss the last Fusion Friday, I did go over CAM in Fusion 360, specifically 2D toolpaths within Fusion 360. So we go over some of the toolpaths that Fusion 360 has to offer, and just some of the basic techniques to go about it when approaching those toolpaths. We also went over how powerful the integration between the CAD/CAM capabilities within Fusion really is, right? So once you have your model and you make a change to it, let's say you already had a CAM set up for your model. If you made a change to your model, you want to make sure that those toolpaths update parametrically as well. So we went over an example of that last Fusion Friday. In case you did miss it though, we do have a channel on YouTube, so feel free to check that out.
And in case you guys missed something important from this webinar, feel free to don't worry, because it'll be on YouTube in a few days.
Right. Yeah. So as I mentioned before, if you have any questions throughout the presentation, please feel free to ask them in the questions box.
So like Alex said, we're doing simulation to make sure you guys make good quality products in the design process before even having to produce it and sell. So that will cut costs. So when, let's say, you do make it and then the customer receives it and then like it breaks or something happens to it, then you have to send it back to the design process, and replacing it and making them a new one is going to cost you a lot of money. Not only that, it'll ruin your brand's reputation. And also, like, let's say you design bikes. If your bike breaks while they're riding it, it'll also jeopardize the customer's safety. So there's all these different reasons why doing simulation is super important.
Right, and I like how you have a warranty on there too, Brian. Let's say your part keeps on breaking and your warranty's taking care of it. Essentially, your company is losing thousands or millions of dollars replacing those items, right? So you want to make sure that your part is going to withstand or just handle the load that is being put on.
Right, correct. So Fusion uses a Nastran solver to run its simulation. And what Nastran is, for those of you who don't know, it's a solver used by NASA. And so everything that you see in space today was tested through Nastran simulation. So it's not a wanky janky solver. It's a pretty well-known one. So like I said earlier, we're going to talk about, I didn't say it earlier, but we mentioned a bike earlier. And coincidentally, we'll be focusing on a bike suspension fork crown today, as you can see here in the picture. So this fork crown will be receiving force from the steering from the top, and then it's being fixed from the wheel at the bottom there. So we'll go ahead and jump into the model that I have here in Fusion. And this one I got from Inventor. I got it imported from Inventor. And if I just focus on the fork crown, this is the part we'll be testing. There'll be a force, like I said earlier, applied up here, and it'll be fixed among these two tubes down here. I have my own model in Fusion 360 that I've created. And okay, so let's get to setting some constraints, putting some loads on this, and testing it. So to get to the simulation workspace, you want to go to your toolbar up here and go to simulation. And the cool thing about Fusion is that if you pause or if your mouse is idle over a certain tool, a little diagram and a little description will pop up explaining what that tool does, and it helps to guide you to pressing the next or to help you using that tool. So now, once I click simulation, there's this whole window that pops up allowing me to choose a study. If you have Fusion 360, you have access to the top 4 simulations. But if you have access to the trial version or Fusion 360 Ultimate, you have access to all 8 of them. So for now, we'll stick with static stress, and I'll hit OK. And Fusion has a left to right workflow. As you can see here at the top, you want to work from left to right like you're reading a book. It's not only that workflow in simulation, but it's also like that for the modeling workspace, the CAM workspace, etc. So first off, you need to know your materials, where your parts are fixed, as well as where the loads are being applied to your model. These are the most important things before even doing anything about your model is knowing these 3 points, because if you got that wrong, then you won't have as precise results. So we're going to go ahead and choose the next thing on the list. Since we already chose static study, we'll choose for static stress, we'll choose our materials now for our assembly here. And as you can see here, there are a few bodies that there's some extra bodies in here aside from these components. And these bodies they're turned off, but I need to suppress them as well. So I'm going to go ahead and hit cancel, then go to the model components here in the browser, open them in bodies. And as you can see, they're turned off. The light bulb's off, but these arrows are still on. So I'm going to go ahead and click these arrows to turn them off, to unsuppress them, or to suppress them. And then I'm going to go ahead and close that tab. And now when I go to choose my material, they disappear because I'm not focused on them. So I'm okay with the tubes being aluminum 6061. However, my fork crown is not 6061. It's actually polypropylene. So there it is. And we're going to leave the safety factor as yield strength and not ultimate tensile strength, because the example I like to use is that yield strength, like when you use a spring, or if you have a metal spring and you pull it apart to a certain extent, it will deform and it won't go back to its original shape. That's passing the yield strength. And if you pull it apart really far and it breaks, that's passing the ultimate tensile strength. So we just want to see the fork crown perform under the yield strength for today. So we'll go ahead and hit OK. So now that we have our material chosen, now let's choose the constraints for this model. So that's the next one on the list here. I know that my part will be constrained based off these faces on the bottom here, because that's where the wheel will be holding it in place. You can also choose different types of constraints as well. And if you press these different axes to turn them on and off, that will release your fixed points in that direction. So if I press that, then it'll be free to move in the X direction and so forth. All right. So now next is the load. So just click on the load. We know that's being applied to this face up here because that's where the handlebar is. And we can choose different types of loads as well. And we will do 6,000 newtons of force. And you can change between the different newtons or the different units here. Okay. And lastly, since we have multiple components, we must use the automatic contacts here. So by clicking on this, once we hit generate, what this will do is if your components are either coincident or within 0.004 inches of each other, then the Fusion will consider it the same part, or it'll consider it all one moving part. So right now, these are 4 different parts or different components, but once I hit this, generate, then it will fix them all together. Okay, so now that I have that done, we'll do a little pre-check. Says the study is ready to go, and I'll go ahead and hit solve. Now the difference between solving it on the cloud and solving it locally. So if you have like an hour-long simulation, if it's a very big simulation, then you're going to want to do it on the cloud because it'll take like if you're working or if you do it locally, you're not able to access it while it's solving. But if it's on the cloud, you can be working on other things on your laptop or working on Fusion 360 while it's solving. And the benefits of that, the power of that is like if your boss is paying you to work and you just hit solve and you're sitting there and the simulation's running and you're not working. You're either grabbing coffee or grabbing some food somewhere. But if you do it on the cloud, which if I click it here, you can see it costs 5 cloud credits. Then you can just push it to the side. You can solve multiple simulations at the same time as well. But since we have a small simulation here, we can do it locally. Also, I forgot to mention when we run or when I clicked the check mark here, it was an exclamation mark before, but that it showed the exclamation mark because the diameter of the tubing was the same diameter as the inner side of the fork crown, and that's why it had the exclamation mark. And the way we can check that is if we go back to the model workspace. Let me put this on hold for a second. So if we go back to the inspect and go to interference, if I check for the interference of my model, then it doesn't show any interference. But if I click include coincident faces and compute it, you can see where I was talking about, where these diameters are the same. It was just Fusion was just warning me that, do you want it to have it coincident like this? But in that case, as I wanted it to. So, okay, going back to that simulation that was, and you can see how easy it was to navigate. to navigate from the simulation workspace to the model workspace. So now you can see that this legend bar pops up. The whole model changed colors in respect to the safety of factor, the different stresses, or even the displacement of the model. You can have different surface probes on this model, seeing if you want to see the displacement on this surface or on this surface. You can also run a simulation or an animation of the simulation, and you can record it as well as an MP4. As you can see there, it's simulating it. Now in the blink of an eye, there's a MP4 for you.
What if you wanted to create a report, Brian, for one of your colleagues?
Oh, yeah. So if you want to send it out to someone who doesn't have Fusion or they want to see it on a piece of paper or something, you can go to results, go to report, and we'll do a little preview of this. And it'll open up in a browser all the fixed points and the forces that you apply to it and the results of it as well. And even it gives you a diagram. So yeah, that's pretty useful. Okay, also, yeah, you can see between the different tests. You can change the different units you want to view it in as well. This one's really cool. If you want to see like where it displaces the most, you can drag this arrow up and it shows you. A better one to view that in is, let's see, safety factor. If I lower that, you can see where it's most vulnerable this part is, as opposed to just the probes. Because you can see that it's also vulnerable here as well, but this is only pointing at the most vulnerable spot. So I want to talk a little bit more about safety factor. So when you have a safety factor, for those of you who don't know, if you have a safety factor of under 1, then your part does not pass the factor of safety, which means that it doesn't pass the yield strength. So going back to the example of the springs, if you apply that 6,000 newtons of force to this part, it will deform, unfortunately, since it's not at 1. So we're going to go ahead and go back to the model workspace, fix the thickness of this part, and then see the factor of safety hopefully increase. So just by hopping to the model workspace here in the toolbar, I'm going to change the diameter of that circumference, or of that circle, and that the wall thickness. So I want to show you guys a quick, this is apart from simulation, but I want to show you guys a quick tip of how to do that easily. So normally you can just go into the sketch and change it manually like that, right? But there's another way to do it without going into the sketch. That's if you go to modify, change parameters, and now you can create variables to control the diameter and the wall thickness. So I'm going to create a variable called circle diameter. I'll make it 35 millimeters, as well as another variable called wall thickness. I'll make that 35 as well. And if I check this star here, you can, if I have a bunch of parameters, I can check this as a favorite, so it'll be easier to have access to. So now we can go back into the sketch. You only need to do this once. And if I enter that variable that I created, for example, circle diameter, it references that window that or from the parameters that I touched earlier. So if I hit the other variable, wall thickness, hit enter, then it referenced it as well. And then when I hit stop sketch, you can see that everything updates. So I don't need to do a new extrusion, a new fillet for all these corners and stuff. Everything updated on its own. So another way to get to this tool quicker, see now I can edit the millimeters from this window, is you can go to modify, go to the tool that this works for any tool, go to the tool that you want to pin to your toolbar and go to add tool toolbar by hitting this arrow. So now if I want to change that diameter, I can just go to that, click here, and it'll pop up for me. Okay, back to simulation. So I fixed the thickness of the crown. So let's go back to the simulation workspace. Now you see an exclamation mark appears saying it's out of date. That's because this is based off the old model. So I'm going to right click it and hit clone study. So it'll have all the same materials, same constraints, same loads and contacts as the first. So this ties into the integration that Alex was talking about earlier that Fusion has.
Right, really powerful tool where you don't have to create a new setup for that or fix your your constraints. Fusion 360 handles that for you.
Exactly. So yeah, now I can just hit solve and it'll do everything like it did in the first study, except with a bigger thickness. So yeah, if you guys have any questions in the meantime, this should take about 20 seconds. You can also replace study 1 with just by rerunning it again. But I decided to create study 2 so we can compare and contrast the two. So now that's done, you can see that now it does pass the factor of safety, as well as it updates the other tests as well. So now that we have 2 studies, we can compare the 2, like I said, by going back to the workspace. Now a compare option appears. So we're going to go ahead and click on that. And we want to compare the first study to the second study. So as you see, as I rotate one screen, the other one rotates as well, because I have this synchronized tool on. And it helps you to really see, like, or compare and contrast, like how like the design that you did improved or it didn't improve, And you can also compare different features like the stresses of these two. So now that you have that result, let's go back to the simulation workspace. Let's make these results even more accurate. So Nastran's solver uses these things called tetrahedrals. I'll show you guys that by going to the mesh view and display here. And these tetrahedrals are these little triangle things that help to compute all of the stresses and strains that you saw earlier. And these, the more tetrahedrals you have, the more precise your results are going to be. And now I'll show you guys how to make even more of these things. So once you have a study that you're comfortable with, we can go to Manage, go to Settings, and you can go to Mesh, and you can reduce the number or the percentage of these tetrahedrals. Once you hit OK, and then you hit Generate Mesh, you can see that there are more. I'm going to go ahead and do that for you guys. I'm going to go ahead and lower that to about 3%. And I'm going to generate mesh. I'm not going to solve it yet. I just want to show you guys what it looks like.
Essentially, you're just refining the mesh, right?
It's not going to be a
more
huge,
nodes.
yeah, exactly. It's not going to be a huge difference. I don't know if you guys can tell, but there are more tetrahedrals here than there were before. So it wasn't a huge difference, but it does add those tetrahedrals to it. And one more thing in terms of being accurate is, and this one's really important, is to do an adaptive mesh refinement. So you can find that at the same location, except I'm going to bring this back to 10% in order to run this adaptive mesh refinement. And what this does, by turning it on high, I'm going to go ahead and run it while I explain this. So what this does is it runs multiple iterations of the simulation. So if it gets like 30 megapascals on the first iteration, and then it runs it again and it gets 35 megapascals, then the next time it runs it again, it gets 33 megapascals, and then next time it runs 33.3 megapascals, it'll start to converge to a certain point. It'll give you a convergence plot. The higher of a refinement that you do run, the better of a result you're going to get. And once it finishes loading here, I can show you guys what that looks like. It also, especially at the critical points, it adds more of these tetrahedrals at those points. So that's very important. So yeah, I recommend running these adaptive mesh refinements once you get a simulation that you're comfortable with or that you're happy with. Now this does take longer to run than just running it without adaptive mesh refinement. That's why I mentioned to make sure you're happy with your results. As you see, the safety factor did go under 1 this time, so keep that in mind that maybe you do need to over-design your part just a little bit more. So then when you do run the adaptive mesh refinement, you'll get a factor of safety. So now this conversion plot pops up. So if you click on that, you can see that it does converge to a certain point, but it does like trail off here at the end there. But what you normally would see is it converges to a particular point. An example here I have in the PowerPoint would be, this is what it looks like normally, is where it converges to a particular point at around 125 megapascals. So yeah, I recommend running this and to get a more precise result. With that being said, that concludes it for the content of the presentation. Now let's go over what we talked about today. So keep in mind that Fusion has a left to right workflow, and not only in the simulation workspace, but in the other workspaces as well. You can edit the dimensions of your part through the parametric modeling or the parameters window without having to go into your sketch. And you can have more accurate results using adaptive mesh refinement. That tool I showed you guys at the end there. which adds more of those tetrahedrals to help you out with the calculations. So we have a Fusion 360 meetup May 23rd at 6 p.m. here in the office, and we will be going over. We will be posting a poll right now to get your guys' insight on that, and we will be going over the CAM part. You want to talk about the CAM part?
Right. So pretty much the way we're going to lay this out is the first 45 minutes of the meetup is going to be regarding CAM. So we're going to be, simulating a part. We could either start it from scratch or do a part that's already been machined. That way we have a finished product. But we want to kind of show the process that someone would take to machine that part. And then after that, Brian would jump over to the 3D printing.
Yeah,
right?
we will be doing a lampshade where we will be 3D printing with our in-house 3D printer, and we'll show you guys how to go from the design of the model all the way to the pre-processing part of the 3D printing. So we'll show you all the way from start to finish, and it'll be a hands-on experience for both CAM and 3D printing. And the cool thing about the lampshade is that you're able to go to IKEA and buy a light bulb, and then actually use that lampshade to put it around that light bulb. It's also a great opportunity to come to this event to network, and there'll be free food and drinks, and you can just meet other people, other locals who are using Fusion 360, and maybe learn something from them or teach them something,
right.
And bring our community closer together.
Absolutely, yeah. So if you do want to go, please make sure to sign up for the poll right there. You should see it on the right of your screen, I believe. So make sure you click on that. All right, so now we're going to open the floor for any questions
Can we see this?
that might come up.
Let me go to the next slide. And here's our contact information. So please email us or contact us if you guys have any questions regarding Fusion or anything you want to talk about. There's a question from Mark. Will you upload the meetup video? The meetup video, what do you mean by that? We will have a meetup link for you guys to join. But the meetup is just, you just come to the office, and then we'll at 6 o'clock on that day, and then we will just start going in, tackling we'll show a hands-on demonstration as well as a little demo of camming as well as 3D printing.
Right.
I don't know if does that answer your question, Mark? And there's no video for the meetup.
So let's see.
Oh, I see.
Kind of like a webinar.
Yeah, okay, that makes sense now. Okay, so he's asking, will there be a video on it if you can't attend the meetup? We haven't decided on making a video for that yet, but that's actually a really good idea. I think we might consider making one for you, maybe, Mark. So we'll let you know.
Okay, so
okay. I think that's it for the questions that we have.
Right. It doesn't look like we'll give it a couple more minutes here just to see.
And keep in mind, if you guys do that CAM challenge that Alex mentioned earlier, there's $100 gift card reward. So if yours.
Right. So we have had a couple entries. I do want to give it a couple more weeks just to see how many more entries we can get in. But if you aren't familiar with the challenge, just find our Fusion 5.8 CAM video on YouTube, and at the end of the video, there's a challenge. So it's a quick and easy way to earn yourself $100 and also share your experience with Fusion 360.
And then Charlie Westcott asks, does your software offer CFD? No, it does not, I believe.
Yeah, no, it doesn't. As of right now, Fusion 360 does not come with computational fluid dynamics.
But if you go back to the different types of study, there are, these studies that you can choose from. If you have Ultimate or the trial version, you have access to those bottom forward as well. It is on the roadmap for the future, though. So if you check the Fusion 360 page from Autodesk, it'll show you you can see the roadmap there of what's upcoming in Fusion, such as sheet metal and in-browser, what's it called? What was that in-browser thing called? I forgot. But you can work on the easy editability features of Fusion in browser.
Right.
The Project Leopard. There you go.
Right. And just to reiterate, the simulation on the cloud versus locally, if you do decide to go solve it through the cloud, you won't be using your computer's processing speed, right? You'll be using the power of the cloud to solve that analysis.
All right. I think that's it for the questions today. I don't think there's any more coming in. So thank you guys for attending. We look forward to seeing you guys at the next Fusion Friday, and especially the Fusion Friday or the Fusion Meetup, May 23rd at 6 p.m. here in the
Brea office.
In our office, yeah. And we'll Alex and I will both be there along with a few other Katif colleagues. So thanks again for watching.
Thank you guys.